All right, in this day's notes, day 5, we are going to put some math into what we know to determine if something can be a triangle or cannot be a triangle. We're not going to necessarily see a shape. So let's know this. The sum of the interior angles of a triangle is 180 degrees. You learned that in Unit 2. So if I've got 3 angles, how do I determine if something can be in measures of an angle? Measures of a triangle. I add them. So, got my calculator handy. 75 plus 20 plus 85. This equals 180 degrees. So yes, these can be angle measures of a triangle. Now, I don't even need a calculator to look at the next one. That is nowhere near 180 degrees. It's actually 20, 40, 60, 68. It's only 70 degrees. You cannot have a triangle with 3 angles that total up to 70 degrees. So let's add the next one. 18 plus 120 plus 42 gives me 180. Can be a triangle. And the last one, 47 plus 53 plus 44 equals 144 degrees. Cannot be a triangle. All right, so remember, must equal 180 degrees. If the 3 angles do not equal 180 degrees, it is not going to be a triangle. It is impossible to draw that. All right, let's look at the next piece. Angle relationships in triangles. Now, what we say is opposite. Angle C is opposite side AB. Angle B is opposite side, AC. And angle A is opposite side BC. What we know is the smallest angle will always be opposite the smallest side. The smallest side will always be opposite the smallest angle. So I'm going to write this there. Smallest side, opposite smallest angle. You do not have to have all the measurements. All right, so let's take a look at this one. In triangle ABC, let's write the sides in order of least to greatest. So I'm going to look and find my smallest angle. My smallest angle is C. So my smallest side is AB. My middle angle is A, so the middle side is BC. It's like you're being Goldilocks. The largest angle is B, so my largest side is AC. And I'm going to call that small, middle, large. Okay, let's do this. Small, middle, large. Now in this triangle, the other ABC, I have side lengths. I don't have angle measures. But the smallest side is opposite the smallest angle. C goes to AB. So the smallest side is AC, therefore the smallest angle will be angle B. The middle side is AB. The middle angle will be angle C. The largest side is CB. The largest angle is angle A. Now let's think about this for a second while your brain's just turning to mush. I'm going to draw a picture here real quick. Okay? Just draw a little picture here. See this little right triangle I'm drawing in black? And you know how we label things A, B, and C in a right triangle? In a right triangle, which is the largest side? It's the hypotenuse, right? The hypotenuse is C. Well, the largest angle in a right triangle is the right angle, which is opposite the hypotenuse. So there's a visual to help you remember. Alrighty, now, let's do that one. You are going to see a question like this in ALEKS. Sometimes it'll be ordering the sides, sometimes it'll be ordering the angles. So you're going to order the side lengths IJ, JK, and KI from least to greatest. But I only have 2 angles. So you add them up. 73 plus 64 equals 137. 180 minus 137 equals 43. So angle I is 43 degrees. Now I know my biggest angle, my smallest, and my medium. All right, smallest angle is smallest side. That would be KJ. Middle angle, middle side, KI. Largest angle, largest side, IJ. That wasn't bad at all. All righty. Now a little more math with triangles. What you've got to do is you've got to kind of compare them, okay? Let's look at the statement. The sum of the length of any 2 sides must be greater than the length of the third side. So in general, what I do is I look for the 2 smallest sides in a triangle and I add them. So I'm looking at these lengths and I'm going to add them. So this 18 plus 8 must be greater than 26. Well, 18 plus 8 is 26. Is 26 greater than 26? No, it is not. So those lengths cannot be side lengths of a triangle. Okay, they must be greater than the length of the third side. 3 plus 3 is 6. 6 is not greater than 15. I don't even have to do any more adding. Okay, oh, digital is so much fun. 9.0 plus 16.6 is 25.6, which is greater. And we know 16.6 plus 24.7 is definitely greater than 9. Alrighty, so these can be lengths of a triangle. My 2 smallest, 12 and 16, add up to 18. 18 is greater than 15. 6 plus 15 is 21, which is greater than 12. And we know 27 is greater than 6. So, first, add 2 smallest must be bigger than other one. Okay, you can, if you go with the 2 smallest, you're probably going to be able to figure it out. But there's something wrong with adding all 3. Alrighty, now we make it all fancy for you. In other words, it's down here. The length of a side of the triangle must be greater than the difference and less than the sum. What? Let's show you. We know that x has to, for this to be a triangle, x has to be greater than 10 plus 16. I'm sorry, it has to be less than. Hello. Because the sum of any 2 lengths must be greater. So 10 plus 16 must be greater than x. So 27 has to be greater than x. That's one end, alrighty? So, which means x is less than 27. So it has to be less than their sum, and then it must be greater than the difference. Well, what's the difference? 16 minus 10 equals 6. So x has to be greater than 6. Because if x is 6, 10 plus 6 is 16. That's not a triangle. But if x is 6.1, it can be a triangle. So let's do it this way. 16 minus 10, 16 plus 10. X is greater than the difference of the other two lengths and less than the sum. In this problem, we're not looking for a number for X, we're looking for a range. The measurement of X can be anywhere between 6 and 27, any infinitesimal amount, but it cannot be 6 and it cannot be 27. It can be greater than 6, less than 27, anywhere in there. That's what we're looking for. Far easier than it looks. All right, guys, that takes care of Unit 3, Day 5.